Good afternoon, everyone. Thank you for joining today's webinar. My name is Augustus Melu, a manager here at Unicom Seminars. We're pleased to be holding a webinar this afternoon titled Why Agile Causes Bottlenecks and How DevOps Teams Can Overcome Them. The webinar is presented by Ben Saunders, Exceed Group, and Eamon Lola, CA Technologies. Ben Saunders is ITIL qualified and experienced in applying ITSM methodologies. His skills profile encompasses a broad technical understanding of software development lifecycle. Ben is also well versed in the practices of data center builds, implementations, and migrations. He shares deep-rooted experiences from the project management and professional services arena, where he has provided consultancy to clients in the financial, oil and gas, and news media sectors as well. Eamon has plenty years in C++ development, designing and writing SOA software for mainframes and I-series. He spent another 10+ years in customer-facing consultancy roles, working in the space of enterprise application integration, SOA, master data management, data quality, and DevOps. Over the last 2.5 years, he spent time helping a range of unwildly organizations adopt DevOps practices. Eamon also holds a master's distinction in software system security from University of Oxford and is an occasional blogger with articles published in Professional Tester. At this point, I would like to hand over to Eamon. There will be opportunities for questions and answers at the end of the presentation, including a prize draw to win an iPad. We hope you enjoy the session and we welcome your feedback also. Over to you, Eamon.
Thank you, Gus. And thank you for the introduction. So I would like to, just to give you an idea of the agenda for the webinar today, I'd like to firstly give you a very brief overview of DevOps according to CA. So CA are market leaders in the DevOps space, so I'll give you a 2-minute overview of our DevOps vision. Agile is obviously part of that, so we'll focus down on Agile. And specifically, we'll have a look at why Agile is hard to do in the real world. And of course, we'll talk about how we enable Agile using software provided by CA before handing over to Ben, who can give you his benefit from his in-depth experience with Lloyds Bank and how they have actually deployed our software and the results they have had with it. So to give you an idea of the CA version of DevOps, we speak about accelerated delivery. So textbooks talk about cycle time. How long does it take to get a change through the complete software development lifecycle? From requirements through to development, through to system testing, SIT, NFT, UAT, right through to production. And we could be talking about brand new applications. How long does it take to get a complete application out to market? Or we could be talking about bug fixes or amendments to existing applications. But in either case, the metric we are interested in, the cycle time, is how long it takes to get through the entire software development lifecycle. In parallel, we want to increase reliability. There's very little benefit to be had by increasing the cycle time if reliability suffers as a result. So we of course want to put in place measures and controls to ensure that we are delivering higher quality, more robust software to the market, albeit at a faster pace. Now, background to this is the increase in complexity. So customers of ours often have distributed, heterogeneous, complex infrastructures, which makes it difficult to really achieve DevOps kind of best practices. It's nice if you are Facebook or a new startup starting with a blank canvas, you can adopt DevOps practices from day one. But our customers tend to be They've got legacy infrastructure, legacy processes, applications. So it's more of a challenge to get these guys up and running with DevOps, and this is what we do. So to give you an idea, I mean, this slide is supposed to represent a general software development lifecycle. So we have developers working in silos on the left, committing code into build servers. It gets pushed through continuous integration servers before proceeding on to various test environments. And the types of challenges that we see with our customers, broadly categorized, would be lack of early testing. So developers tend not to have opportunity to test certain user stories simply because they don't have end-to-end environments available. We talk about difficulty in managing releases. So composite applications tend to be difficult to lift and shift through various non-production environments. System testing environments looks completely different from NFT environments. So migrating the applications through these environments is a challenge. We talk about a lack of automated testing. So given that as an application migrates through these environments, lots of things can go wrong, and even innocuous changes can have impacts in production. So automated testing, the goal behind this is to ensure that we catch issues as soon as they are caused. Automated testing gives us a means of ensuring that the software does not suffer as a result of...
Excuse me, Eamon, it's Gus. Just to point out, the slides are not changing.
Thank you, Gus, for pointing that out.
Sorry about that. Sorry about that. Yeah.
No, that's good. Can you see Enterprise DevOps now?
Yes.
Oh,
Thank
okay.
you.
Okay, apologies for that. So yeah, this is basically highlighting areas of challenges we see with customers in achieving DevOps capabilities. Another general category of challenge for our customers tends to be lack of visibility into production applications. So how are our end users using the system? How is the system responding to that use? Are there peaks in demand, as users all log on at a similar time? Does our system suffer in terms of performance, etc.? These are generally categories of challenges that our customers have in achieving DevOps. And CA has a range of solutions to address these challenges, all under the banner of DevOps. So we talk about true Agile development, ensuring developers can work in a more Agile manner, adopt practices from the Agile Manifesto, even though they're working in composite applications. We talk about continuous delivery solutions, whereby we automate the migration of applications through the software development lifecycle, thereby reducing manual effort and obviously manual errors associated with that. We talk about continuous validation, whereby we put in place mechanisms to run automated regression tests. And these regression tests can happen anywhere. They can happen even right back at development time. The idea is that we can catch issues as soon as they are caused, rather than waiting for later stage regression testing cycles. And of course we talk about data mining. So the ability to capture maybe production data and turn that into useful test data, or capture metrics about how the application is used and reuse that information in a non-production context. So for today, the focus specifically is on Agile development. So this is one sort of cornerstone of the CA DevOps story. And we'll speak mainly today about service virtualization. So going back to basics really, kind of cornerstones for Agile. Some of the goals of Agile: short development cycles, iterative development cycles. So if you think of practices such as rapid application development, RAD, it's all about increasing the velocity of development life cycles rather than one monolithic start to end multi-month or multi-year project. We like to talk about working prototypes. So the idea that you can have a working version of an end result such that end users can play with that. And this very much is supported by JAD, Joint Application Development, whereby end users have something to feed back on. And another cornerstone for Agile is the ability to respond to change. So this was the problem with monolithic waterfall approaches. They did not cater for change. There is a dangerous assumption with waterfall approach that at requirements stage, the requirements would not change between then and production. But of course, that's not the case. Requirements evolve. We learn new things about how the application is going to be used as we go. So Agile is among other things, a means of embracing change and adapting to change. So when it comes to development life cycles these days, Agile tends to be very difficult to do. The reason for that is most applications these days tend to be some form of composite application. And composite applications are very different to monolithic applications. A composite application is distributed, it's heterogeneous, you've got different technologies involved, perhaps even different time zones. So when it comes to running a business process on a composite application, we have this innate dependency on the entire system to be available. If it's not available, we cannot run user stories, we cannot run end-to-end tests. And that becomes a challenge for Agile. For development or testing, we've got a bunch of constraints that you wouldn't tend to find with old school monolithic applications. And these are just some of the examples of constraints. So limited access to systems. Some of our customers have back-end mainframes which they would like to have available for development and testing purposes. There is a cost and time to provision test environments for developers and testers to play with. Pretty much all of our customers complain about environment availability. So where non-production environments have been made available, unavailability tends to be quite high. There may be limited access to third-party services, so think perhaps credit check agencies or payment providers. Services may not yet be developed. So in service-oriented architecture, SOA, it's quite common that some of the components are themselves under development. So how do you test end-to-end processes when some of the components don't yet exist? There's also, of course, a cost associated with provision of non-prod infrastructures, so hardware, software, ongoing maintenance, and test data. The provision of test data that can be safely used, refreshing of test data, etc. These are all examples of constraints that restrict the development and testing activities. If we didn't have these constraints, Agile would not be a problem. We could spin up as many environments as we want, rapid application developments, joint application developments. There would be no issue about that. But this is the reality of software development today. So these constraints really sort of shape the problem space from which service virtualization has evolved. Now, service virtualization is one of the key tools in the CA DevOps arsenal. Now, what service virtualization does is provisions virtual endpoints to be used by developers and testers. So to give you a sort of diagrammatic overview of how virtual services work, let's assume that this guy here is a developer or maybe a tester and responsible for the development of this component. So this could be an application server, it could be an ESB, it could be a Java application, doesn't really matter. But the point is that in order to fully test this component, we need access to some downstream system. Now this may be a mainframe or it could be a third-party interface, it doesn't really matter. So the point is that we are responsible for development and testing of this component and need access to that component in order to fully test it. And all of the constraints that we spoke about before apply to this downstream component. So CA have a product called Lisa, and Lisa is basically the product that we use for service virtualization. One of the ways we can use Lisa is sit Lisa between the components that we are developing or testing and the downstream system. And in that manner, Lisa can listen to traffic passing between them. So the traffic will be some form of request response traffic. Maybe it could be XML traffic over MQ, it could be web services, SOAP over HTTP, or it could be KIX transactions, any sort of conversational traffic. And from that listening, Lisa builds what we call a virtual service. And the virtual service is, in effect, the learned behavior of the downstream system. So the virtual service is obviously going to be something that we can use in place of the downstream system. Now, for many reasons, a virtual service is, in fact, more useful than a physical downstream system, because a virtual service is synthetic. We can control it, we can extend it, and we can do things with it that you could not do with a physical downstream system. So one example is for test coverage. It may be difficult to get certain responses from a physical downstream system. Maybe certain error responses are hard to reach. But with a virtual service, we can manipulate that virtual service and tell it that we want to see this response whenever we send a certain request. So it gives us a means of very easily extending our test coverage. Another way virtual services can be very useful is for performance testing, because another thing that we can control here is response times. And response times are very interesting for a performance testing context. If we want to understand how our application reacts when downstream response times increase, that is difficult to do with physical hardware. But with a virtual service, we can obviously fully control the response times from our service. So we can replicate worst case scenarios in production. We can understand how our application is going to break. Will it degrade gracefully or will it fall over? These are all things that we can do with virtual services. Now obviously the end goal of this is that we've got something that can be used in place of the physical downstream system. And this virtual service is something that can be used by as many developers or testers in the organization. So we eliminate all of the constraints associated with systems. We provision something that is commoditized, that is lightweight, that can be used by developers or testers. So this is kind of transformational when it comes to software development. So to go back to our composite environment overview, just some examples of where virtual services may be used. If we are developing or testing some front-end UI, we could use our virtual services to take the place of everything downstream. So VSE, by the way, is our terminology, virtual service environment. It's the runtime environment for virtual services. But basically, this may be a developer who takes his application home over the weekends and takes a virtual environment home on the same laptop. So as far as this component, this application is concerned, it is talking to a complete end-to-end environment. So that's got interesting implications for developers and testers, such that they don't need access to downstream environments. Another pattern of use for virtual services is that we can isolate any components in the infrastructure. As far as the component is concerned, it is sitting within an end-to-end environment, but we're actually virtualizing both upstream and downstream traffic from that component. So we can take any component in the infrastructure and convince it that it is sat within an end-to-end environment, even though we're just using virtual representations of upstream and downstream. And that becomes very interesting because some of the things we can do here are, for example, automated regression testing. So with this capability, we can run a full regression suite on that component, and we can do this whenever we want. We don't need to wait until we've got an SIT environment or an end-to-end environment. This regression test can be done even at development time, as many of our customers do. And of course, we can virtualize entire infrastructures. One of our first large customers to use this product coined the phrase bank in a box, because they used it to virtualize an entire back-end banking infrastructure. And this could then be used by, this could be hosted on a laptop or it could be shared between development teams. They even used it for offshore development teams because the virtual endpoints, of course, contained no sensitive data. So the benefit of this was that they could give this to offshore teams without needing to worry about security compliance or sensitive customer information. So I'll finish on this one slide. It's I attended a talk at Gartner Application Development Conference last year in London, one of the Gartner analysts gave a talk on Agile practices. And I enjoyed his talk mainly because of this one quote that he gave. One of the key themes of his talk was how service virtualization is actually nearly a prerequisite for doing Agile. He appreciated the fact that in composite environments, in complex real-world environments, you cannot actually achieve Agile development practices without tools like this. So on that, I will hand over to Ben and let Ben introduce himself and tell you all about how this is used in the real world.
Thank you, Eamon. Afternoon, everybody. So my name is Ben Saunders. I'm a senior consultant for Exceed Group. So I'm going to present to you today about a real-life scenario and implementation of service virtualization and an implementation of the CA Lisa toolset within Lloyds Banking Group. So without further ado, I'll move on to the next slide. So what I'll start off with is just explaining the example benefits to date and what has essentially been achieved so far in using the Lisa toolset across the group. But after that, I'll also touch on the reason as to why we looked at adopting CA Lisa. And Eamon made some good points earlier with regards to the various contentions of test systems and multiple projects trying to get through test environments at the same time. So I'll explain the rationale behind our client's desire to use the CA Lisa toolset. And then I'll give an example roadmap and the adoption steps that were taken to implement CA Lisa within the organization. And ultimately, after that, I'll start to allude to the points around establishing a center of excellence to help drive the adoption. Eamon made some good points when we touched on about breaking down barriers between testers and developers. That's very much what DevOps looks to do. But ultimately, when you're trying to introduce any new tool set into an organization, you're always going to build resistance and face resistance. And ultimately, we use the center of excellence as a vehicle to help remove those blockers. And then I'll also just talk about the implementation approach and how we get CA Lisa embedded in projects at the very start of the life cycle, so as to ensure that we can derive and deliver as much benefit as possible in terms of our return on investment. So in terms of main benefits that have been achieved so far within the organization, so headline of numbers there. So we've virtualized around about 700 APIs and certainly a number of testing systems across the development, functional test, and non-functional test arena. Consequently, off the back of that, we're probably sitting on around about £3.8 million worth of cost avoidance and cost saving. Some of it would be wooden dollars and money that has been recuperated internally, but we're also now starting to see figures being recuperated through the virtualization of external interfaces and CapEx that would have actually gone out of the business. So we're really seeing a great deal of value there. You will hear the term shift left coined an awful lot with service virtualization in the CA Lisa toolset, and that's really by empowering developers and testers to perform early testing much sooner in the life cycle. And consequently, by being able to do early SIT in the ST phases, we're able to identify defects much sooner. So we're actually seeing defects and a greater number of defects detected in development as opposed to system test and system integration test. And obviously there is a pound element or a dollar element that we can attribute to defects that are detected much later in the life cycle. And if we can identify those defects, prevent defect leakage, we're going to is the virtualization of a single API. So this single API was really troublesome. It required an end-to-end test environment to be provisioned, and essentially the QA department had quoted 56 days to the business in order to prepare the environment, ready the testers, ensure that the relevant test data was prepared, execute the testing, and then to generate the end of test reports. For using CA Lisa, we've removed the need for all of those interdependencies, and we can now go ahead and test that API in one day. And that is to cover all of the previous points that we were talking about there. So it's actually a 99% reduction in the development and testing overheads that we were quoted by our QA department. You know, faster time to market, and ultimately the business is happier because we don't need to spend as much money as we were previously quoted for them. Some other additional benefits that we've derived, creation is 1 person day. Automated regression testing, we're seeing 70% reduction in the amount of time it takes us to perform regression testing. And there's just a great number of additional benefits that we've started to see through the use of CA-LISA across the organization. I'll move on to the next slide. So really, what was the business reason for us to choose CA-LISA? As I mentioned at the start of the presentation, typically in any large organization where we have a heterogeneous environment stack, there's always contention between multiple projects trying to get through those testing systems. And ultimately, when we don't have those testing systems available, we would spend a lot of time coding stubs or simulations of those environments to enable us to push through our various testing phases. Ultimately, a lot of the time, those stubs don't necessarily give us a more system-like or realistic response to how the system should behave. And a lot of time is spent coding a stub, verifying whether or not it's fit for purpose, and we tend to spend a lot of time coding from the ground up and creating test data. And that's not essentially a very realistic representation of the testing ecosystem. We also provision a great deal of test environments on an annual basis, you know, circa around about 2,000 test environments, and I expect it's a great deal more. And then we've got the complexity of those test environments and how they all hang together. So for instance, you can see in the left-hand diagram the as-is infrastructure. So if one of my backends becomes unavailable, you know, testing and development practices tend to halt. So through using CA-LISA to simulate that environment, we're able to give a more system-like response. If the environment becomes available, we can readily deploy the virtual service in its place. And then ultimately what we're looking for is a 100% testing and development availability for our testing and development community. So again, a system uptime, system availability will ultimately allow us to improve our efficiency, improve our productivity, and ultimately improve our time to market for our customers. And I guess one of the most important things that we were looking at there is the reduction in real environments. So if we're building a great number of environments on an annual basis, it's going to cost us a lot of money. And ultimately, it takes us a lot less time to provision a virtual service. We're usually looking really at just a license to use CA-LISA, and also the resource time to build that virtual service. Whereas ultimately, if we're building a physical testing environment, we've got the hardware costs, we've got our internal service delivery costs, and then on top of that, any additional license fees and resource costs in order to deliver it. So ultimately, we're looking at reducing the total footprint of our testing and development environments, but also the costs associated to those overheads of maintaining them on an annual basis. So you can just see here, what I've tried to do is illustrate the CA-LISA implementation roadmap and how we got it into the group in order to ensure that we could deliver the benefits that we had seen on the CA-LISA marketing material. So our initial adoption dates back to 2012, where we went through a product evaluation, and we investigated a number of tool sets that were available on the market. And consequently, as a byproduct of that product evaluation, we approved the utilization of CA-LISA within the group and started to liaise with CA in order to get this embedded in the organization. As a result of that, we conducted several pilot engagements, firstly in the digital banking platform and in our service-oriented architecture platforms, where we started to realize a great deal of benefits across a number of our key and core back-end testing systems. And consequently, off the back of that, we procured a number of licenses which would enable us to utilize CA-LISA across the functional test and non-functional test elements. I think one of the key points to recognize here as well is that as we were going through that proof of concepts and pilot pilot phases, we were conducting a great number of SV awareness sessions. So as mentioned at the start of the presentation, you're always going to have the naysayers, you're always going to have the doubters, and you're always going to have people who are reluctant to the change. And we very much felt that these service virtualization awareness sessions were very key in order to break down those barriers, socialize the tool set, and ultimately start to turn people's perceptions around of what CA-LISA was and potentially how it could always deliver benefit to them. And I think that's probably one of the key points that I would suggest here, is that you need to make service virtualization personable to the people that you're talking about. Everyone has their own constraints, everyone has their own blockers, and I don't think you should necessarily look at CA-LISA as purely a virtualization tool, but you can also use it as a test injection tool. So testers will get a lot out of it, your environment build guys will get a lot out of it, and ultimately your developers will also get a lot out of it as well, because they can use it to help them drive the design of their services, which is ultimately a great deal of benefit for them. So as we've gone through the SV awareness sessions, we've then entered into a full engagement with CA, and we've undertaken a number of what we term value releases. And you can see a value release is essentially a 8 to 12 week engagement where we look to address constraints across a number of projects along our portfolio. And through using CA-LISA, we want to remove those constraints and ultimately deliver value through virtualized test cases, virtualized environments, or whether that be automated regression packs. So we performed those value releases, and what we were keen to try and do is understand and get those value releases associated to projects at the start of the life cycle, or at least projects which were at the start of their sprint phases, so we could understand A, how well they performed in the first instance, and then B, we could then have a reflection during the second sprint phase and understand how much value CA-LISA brought to the table. So again, that was a really key component in us being able to socialize and illustrate the benefit that CA-LISA was bringing to the organization. What we also did in parallel to that is we undertook the design and build phase of our strategic infrastructure for our early adopters of the toolset. And one of the key components of the delivery was to establish a center of excellence. So using the center of excellence as a vehicle not only to help build virtual services for early adopters, but it was also essential that we established an internal training framework so that we could educate our user community and also establish best practices and governance features so that we could ensure that everyone was building virtual services and test cases to a coherent standard. What we didn't want to do was deliver a new tool set, revolutionize the way that bank worked, and then ultimately have people working in silos to various standards and governance practices. If we had that, we would essentially then have chaos because people would be provisioning virtual services and test cases to different standards. So we really use the Center of Excellence as a vehicle to ensure that standards and governance happen in exactly the same way across all of our adopting platforms. What I would say is, as we were going through the COE creation, we had a number of additional platforms that were very keen in order to adopt the tool set. So again, we used the same approaches whereby we performed a number of proof of concept exercises, and then ultimately some extended pilots whereby the platforms then procured their own licenses for functional testing purposes. And during that engagement as well, we actually converted a number of adopters of the Green Hat solution to CA-LISA, which we actually did in a very, very simplistic way. And we're also performing some migrations from proprietary stubbing mechanisms as well across the group, which again was a fairly seamless exercise when we were using the CA-LISA toolset. And then ultimately, through the great work that we'd managed to achieve in that year in collaboration with CA and also with a number of our partners, we managed to agree an enterprise license agreement with CA for the LISA toolset. So ultimately now we've got to a point whereby pretty much all of the platforms in the organization are slowly but surely starting to adopt the toolset, and that's actually now allowing us to capture a great deal number of additional benefits which we are sure to do with the Center of Excellence. I would say that that's the one thing that you really need to consider when you're adopting any such tool set, is always be sure to measure the value. How good were we before, but ultimately how much better are we now with CA-LISA or with any kind of service virtualization tool set, and what's the value that's been brought to the organization as a result of that change. So as I alluded to over the last slide, one of the key components of introducing the CA-LISA toolset and ensuring that it was a success was the establishment of a Service Virtualization Center of Excellence. And actually there's kind of 4 key pillars to our strategy. Ultimately, we provide a managed service solution for our consumers of the CA-LISA service. So ultimately they can get on with what they have to do in terms of ensuring that they're delivering for their projects. So we look after the underlying infrastructure which we run the application from. We provide the projects with support in terms of how do I get CA-LISA into my project, how do I manage and measure the value, but ultimately what does this mean to my project plan? Eamon suggested at the start of the session that we could position CA-LISA in between our application layer and our back-end infrastructure. So helping projects understand the demarcation points and how they do that and how they factor it into their project plans is something that the Center of Excellence gives them guidance on. We give them technical expertise, so we liaise with projects as they come on board and understand what are they looking to virtualize. We give them the internal training and competency building. We share best practices and give them the knowledge transfer required to get them up and running. And actually what we try and do as well is get into the projects early in their life cycle and early in their study and requirements phases so that we can understand the constraints that are coming up, and then we can also consult with them and say, what is it you're looking to virtualize? We can then go and consult and dissect our internal virtual service database, and if there is something that's fit for purpose, we can give that project a virtual service of the simulated environments that they require for testing much sooner. So I think we had an example yesterday in our organization whereby someone said, I need this API, is it readily available? It was already there, the test data was fit for their purposes, and ultimately the project no longer had to wait 3 or 4 weeks for a test environment to be provisioned. So yet again, that's a clear example of the shift left practice that we're looking to instill whenever we adopt service virtualization. And ultimately, as I said as well, there's always going to be a need for a service management element within the Center of Excellence. Whenever you're introducing any new tool set to the group or your organization, it's important that you administer and look after that infrastructure in a sustained manner. So the organization benefits of looking after the licenses, various versioning control, the infrastructure management, and then any associated upgrades to the application. That's all managed through the Center of Excellence to ensure that the projects can really focus on their delivery functions. And here I've just put together an example of how we implement service virtualization into our projects. So at the start, we'll always define the requirements with our consumers of service virtualization. And ultimately, when we define the requirements, that will allow us to utilize the best virtualization approach. So one of the great benefits of CA-LISA is that you can build virtual services for a number of manners. We can take WSDLs and XSDs, we can use request response pairs, or we can also use the recording function, which Eamon alluded to at the start of the presentation. And as ever, we can always code from the ground up. So defining the requirements and understanding the need of the consumer enables us to decide upon the best virtualization approach. Prior to any such engagement as well, it also gives us an opportunity to ensure that we've got the relevant KT embedded in the organization and in the consuming project, and it also gives the Center of Excellence an opportunity to ready any infrastructure that may be required for the engagement. Once we've done that, we work and collaborate with the project in order to ensure that they are in a position to start building virtual services. A number of occasions our Center of Excellence has built virtual services purely for the consuming projects. But what we try to do is ensure that we collaborate. And through that collaboration, we can then ensure that the project becomes fully conversant in the use of CA-LISA. And ultimately, once that project closes down, the resources return to their support functions and their delivery platforms. And ultimately, we're hoping that you get this ripple effect whereby the users and the consumers of CA-LISA ultimately become conversant, and the COE no longer becomes a bottleneck the asset creation of the virtual services, test cases, and associated regression test packs. Once we've gone through that build and execution phase, it's always important to have that benefits realization checkpoint, not only for understanding as to how much benefit you've derived through CA Lisa, but it's always a good news story to be able to articulate that to the business and also to your senior management stakeholders, the people that ultimately gave you the thumbs up to utilize the tool set. It's always good to give those good news stories back up to the organization and just gesticulate how much benefit CA Lisa or the tool set of choice has delivered across the portfolio of projects. And then what I've also put at the bottom of this slide is just an illustration of project pipeline and adopting platforms that we are looking to bring on and get them fully conversant in the CA Lisa toolset across the organization within the next 2 years. We very much have a staggered approach, so that it means that the critical mass of the Centre of Excellence can ensure that we are fully focused on our various engagements. But what I would also say is that we always look to deliver a great deal of value for those ad hoc requests that always become apparent for projects which may not have yet adopted the CA Lisa toolset. So it may be that we've got some constraints around a test environment, we might not yet have our test data provisioned, and ultimately we use the Centre of Excellence almost like a parachute professional services or software delivery firm, whereby we can drop somebody into a project and remove those constraints from the life cycle sooner rather than later, ultimately getting those projects back from red and into green, which is ultimately what we really want in terms of our delivery schedules. So I think it's the closure of the SV presentation from an implementation perspective. I think we'll open up the call now for some questions. And if there is anything that we'd like to, I'd probably hand over to Gus and see if there's anything else that's out there on the phone.
Just while we're waiting, there have been a few questions coming through.
Okay, so we've got a first question that's popped up and that said, which are the best projects to use SV on in the early stages? So I'll happily take that question. I think when we're looking at SV, it's always a challenge to try and kind of change those testing and development conventions that we use across the life cycle traditionally. What I would say is that we typically look for projects that aren't necessarily unconstrained in the first instance. Those that are at the start of the life cycle or are in between sprint phases, because if we've got those people that are at the start of the life cycle, we can start to understand their requirements. We can go through a requirements gathering phase, and then any assets that we need to build the virtual services, we can get them sooner rather than later. As I mentioned as well, it's good to identify projects that may be in between those sprint phases, purely in the early stages when we're adopting CA Lisa, because we can understand again how the first iteration of the sprint went, what were the blockers, what were the constraints, and then we can come to the next sprint and say, right, this is what caused us a headache last time, let's use Lisa to remove those blockers, and then ultimately understand how much better Lisa was in terms of a measurement value once that's been implemented. Okay, so we've got another question that's just come through as well. So the question is, what impact does it have between development and testing teams? So I think traditionally we can always say that development teams and testing teams have a great deal of contention between one another. There's always some associated hatred. But what I would say from our experiences of using CA Lisa is that it's very much brought testers and developers closer together. So I think from the utilization of the tool set, testers start to have a greater understanding of the development community's utilization and how they would necessarily build a service from the ground up. And ultimately what we're also seeing is a greater collaboration between developers asking testers what is it they're actually testing, what are their test data needs, so that when they're building their virtual services, the test data that's contained within them is definitely more closely in sync with their requirements. And that's actually broken down the barriers between our testing and development communities and actually started to deliver a lot more value, because we're not having this contention whereby testers are complaining that the service that's been built isn't up to scratch, and then developers are turning around and saying, well, you didn't necessarily give me the requirements in full for what it was you wanted to test.
Another question which has just come through, is Lisa used in production or only pre-production? So Lisa is just for pre-production. So the idea is that we use Lisa to simulate environments, but this is purely for development and testing purposes. And the idea is that we give developers and testers the opportunity or access to environments, which allows them to get through more test cases, deliver software of higher quality into production. So even when it comes to recording, one of the ways we can create the virtual services to record, as we illustrated earlier, that recording should even be done in pre-production. And typically that is done in something like a UAT environment. So technically there is no reason why you could not do this in production, but the software is not designed for use in production. There's another question, why or how is virtual services, how are they different from mocks, or what is the difference? I mean, virtual services are, some people describe them as mocks on steroids, which is one description, but there are some cases where mocks are sufficient. I remember one workshop, extensive workshop with an insurance company, where we did a whiteboarding architecture session, and after 2 hours we had identified the root cause of all of their constraints down to a single web service interface. So the account director was delighted that we could sell them Lisa to address this constraint, but we had to point out that this really wasn't, they didn't really need Lisa for this. If your interfaces are very basic, stateless kind of web service interfaces, you probably don't need it to like Lisa. What Lisa gives you above and beyond mocks or stubs is the ability to handle more complex interactions. So once that interaction becomes stateful or conversational rather than stateless, then your mocks or stubs become a bit more complex, difficult to maintain. Lisa is designed out of the box to scale. So Lisa is commonly used in performance environments where it may be handling 20 million transactions a day. These are things that you will not easily do with mocks or stubs. And Lisa has been around for many years. It's 7th generation. We have hundreds of enterprise deployments behind us. And from that, the extent of protocol support has expanded over the years. So we support a huge array of message protocols, EDI, XML, CSV. We support transport protocols, HTTP, JMS, MQ, etc. And of course a range of security protocols. So these are all functional benefits over mocks, but I guess there are non-functional benefits as well in terms of when it comes to maintenance and management. Having Lisa means that you've got one enterprise solution for virtual environments. And many of our customers find that they have in the past spent a long time, development time, building their own mocks and stubs. So there is of course a cost associated with that. That's valuable development time. But there is also a fact that these are all developers doing their own versions of interfaces rather than a single holistic standard. Another question, how long does it take for a knowledge worker to become proficient in using Lisa? We have standard training programs to bring people up to speed. One of the core elements of that training program is a 3 to 5 day course, an introduction to Lisa Service Virtualization. And we would expect that at the end of that course, an attendee could be proficient and useful. So the idea with Lisa is there is no coding involved. This is a configuration tool. Lisa is designed to do nothing other than create and maintain these virtual services. So the knowledge overhead is minimal. What the kind of skills you do need would be more architect type skills, somebody who is familiar with the various protocols you might need to deal with. What is HTTP, what is JMS, what is MQ, what is XML. but we're not talking about development skill sets. Any more questions coming through? There's another question, how does Lisa help with continuous integration? Some of our customers have already taken steps towards continuous integration or even continuous delivery. But one usage pattern that we have seen, which is very nice, is customers who have a build server. So developers check in code to a build server. Build server picks up that code, compiles it, and generates an artifact, maybe a DLL or a Java bean or whatever it happens to be. But using Lisa, we can plug into that continuous integration server and generate a test that runs on that artifact. So I think I mentioned this earlier on, the idea of doing early automated regression testing. So we can plug into a continuous integration server and have complete regression tests run in an automated, headless manner on that artifact without having to wait till later stage testing environments where we've got manual testers running through manual regression test cycles. So that is one example of how Lisa can assist with continuous integration.
That concludes the question and answer session as well as the presentation. We would like to thank both Eamon and Ben for the brilliant presentation. And at this point, we would like to remind everyone we will go to the prize draw to announce the iPad winner. The winner for the prize draw is Andy Birds. We will be in touch shortly with the iPad. Thanks everyone for joining today's webinar. We'll make the recording available afterwards and we'll send you the feedback and link. Thanks again. Cheers. Bye.